All right, in this video, we are going to work the following problem. It says solve the following equation for theta on the interval from 0 to 2 pi. And the equation is 7 tan theta minus 2 equals 10. So the first thing that we're going to do is use the rules of algebra to solve for the trig function. So the first step in doing that would be to add 2 to both sides of the equation. That will leave us with 7 tan theta. So now we have a little bit less with the tan theta on the left side. And then we can get tan theta completely by itself on both sides by dividing both sides by 7. So here 7 divided by 7 is just 1. And so we get tan theta equals 12 sevenths. Okay. Looking at this number over here, 12 sevenths, that is not one of the values, right, that's on the usual special angles on the standard unit circle, or the standard labeling of the unit circle, right, for the special angles. So we are going to have to use our calculator to do this one. All right, so we're going to do theta equals tan inverse of 12 sevenths. And so on Desmos, I need to do that as 12 sevenths, and we are in radian mode, which is correct. And so we get theta equals, or is approximately 1.04 to 2 decimal places. All right, and so now, though, we have to be a little bit careful. We want all of the solutions, right, in 0 to 2 pi. And so the first thing that you need to remember is for tan inverse, right? Tan inverse is going to give you answers from minus pi over 2 to pi over 2. So in this half of the unit circle. And not only that, if it's going to be from minus pi over 2 to pi over 2, right? If the number that you're taking the inverse tan of is positive, it's going to give you an answer that's in the first quadrant, which is in our range, right? We want 0 to 2 pi. If the number that you're taking the inverse tangent of is negative, it's going to give you an answer from minus pi over 2 to 0, which is not what we want, right? In this case, though, however, it is positive, so that means the angle that we're looking for is somewhere up here, okay? And so there is an answer up here that we want. Okay, and so then there is another answer, right? And if we look at the tangent in the second quadrant, it's going to be a negative, right? And in the third quadrant, it is going to be a positive down here. So the other answer is going to be down here in this quadrant. All right, and it's going to be 180 degrees, or pi units, away from this other, this answer that we got up here in the first quadrant, okay? And so to see that a little bit why that would be so, right, let's take a look at this one. We can kind of see that that's true for these ones on the unit circle, right? If I look at this side, pi over 3, square root, the tan is square root 3. If I go 180 degrees, that would be down here at 4 pi over 3. We can see that it has the same value down here. And you can see it's because the points, right, have the same coordinates, but just opposite signs down here. So when we do the second coordinate divided by the first coordinate, it comes out the same down here as well, okay? And so what we're going to have to do, right, on these inverse tangent problems is to calculate whatever it is pi plus, or whatever the answer for theta is. This answer theta right here, right? It's going to be theta plus pi to get to the other one. Another way you can look at that is that this angle would also be theta, right? The angle between the negative x-axis and the terminal side of the angle that we're looking for is also going to be theta because they're vertical angles, right? And so that's another way to kind of see that this would also be an answer. All right. So what we're going to do then is to do theta is tan inverse 2/7 or 12/7 rather plus pi and go to the calculator and do that. And that's going to give us 4.18 to 2 decimal places. And so that will be your other answer in this one. Okay. All right. And that is it for this problem.